Now let's look at the construction of the confidence interval for a population proportion. So the confidence interval is a range of reasonable values that the population parameter could fall between. It is not a guarantee that the parameter value will fall in this range, but there is a predictable probability of success that it will fall within that range. So a confidence interval contains two parts, the point estimate and the margin of error. The point estimate we already talked about, that's our starting point, our best guess for what the value might be. And then the margin of error represents the range of uncertainty or variability around the point estimate. So the margin of error is an amount that is added and subtracted to the point estimate to give us the range of values that the parameter may fall between. So the equation for a confidence interval for proportions is p hat plus and minus. So this part here, the plus and minus, means that we're going to do the equation twice. Means we're going to do it once going through adding everything, and then we're going to go through again subtracting everything. So we're going to add, and then we're also going to do it again and subtract. So we're going to do this whole equation twice. It's not how you spell subtract. There we go. Then we have a z-crit. This guy represents a z-score. And there's more details on that below. And then we multiply that by the square root of p hat times 1 minus p hat divided by n. This equation should look somewhat familiar. This is our standard deviation formula for proportions. The only difference is we don't know what p is. So instead of using p in this formula, we're using p hat because, again, p hat is our best guess for what p could be. So the z-crit is a z-score for 1 minus alpha divided by 2, where alpha is 100 minus the confidence level. So when we do our confidence intervals, we are going to be given confidence levels usually of 90%, 95%, 98%, or 99%. You could get any percentage for how confident you are, but these are some of the more common ones. So if you have a 90% confidence interval, alpha is 100 minus 90. So alpha is 10%. And then the z-score is found by taking 1 minus the 10% as a decimal, dividing that by 2. So that's 0. 0. Sorry, I'm looking at my formula and I actually wrote it down wrong. This should just be alpha divided by 2. We already did the 1 minus. I'm 1 minusing too many times here. As I'm doing this, I'm like, that's not right. Okay, alpha divided by 2. So this is 0.05. And we would plug this in to Excel to find out what is the z-score with this value. And we will see all of this in an example. Do not worry. And then, as I already said, we don't know what P is, so we use P hat as our best guess. So that's why instead of P, we are using P hat. So it's our point estimate plus and minus a z-score that is based off of a probability, and then it's multiplied by the standard deviation. That is how we create the confidence interval. The margin of error is the piece that is added or subtracted. So the margin of error is the z-score times the standard deviation. So this E stands for margin of error. And it is the z-score times the standard deviation. It is also, this is the piece that is added and subtracted from the point estimate. So these are the formulas that we are going to use to create our confidence interval and also to calculate margin of error. Once we have our confidence intervals, we want to write out an interpretation. So the final piece to any confidence interval is to interpret our confidence interval. Our interpretation should contain a few key pieces. It should include the confidence level. What was the percentage of confidence we were given? What parameter is being estimated? So in this case, we are looking at the population proportion. Context towards what it is that we were estimating. And then the range of the confidence interval converted into a percentage. Converting into a percentage is optional, but it goes a long way towards helping the interpretation be a little more grabbable, easier to understand. So I have two different ways that you could interpret a confidence interval for proportions in very basic language. So we estimate with a given percentage of confidence that the true population proportion or percent of whatever it is we were looking at is between the lower bound and the upper bound. The lower bound is calculated from doing the subtraction, and the upper bound is calculated from doing the addition. An alternative interpretation is to say we estimate with the given percentage of confidence that between lower bound percent and upper bound percent of whatever it is we were looking at. So these are in very generic terms. Once we're doing some examples, this will be a lot easier to understand what I'm trying to say here. Okay? So this is the math and formulas behind what we're going to be doing, and then also a general idea of how to do the interpretation.